Okay, so still looking here at 2013. I'm just going to have a look here at one part F. Okay. What we're asked for here then is I'm asked to calculate the concentration of iodine in the sample bottle in moles per litre. So I'm just going to have a look at what I have. After the 3 additions, the thoroughly mixed contents of the sample water were titrated in 200 centimetres cube portions. Okay, so that means I have 200 centimetres cubed of iodine here, and they were titrated with the 0.02 molar sodium thiosulfate, with the average titration figure as 9.4 centimetres cubed. Okay, so what I'm asked here is to calculate the concentration of iodine in the sample of water. So I have 0.02 molarity means moles per litre, which is 1000 centimetres cubed. I only have 9.4 centimetres cubed in this particular question. So 0.02 multiplied by 9.4 divided by 1000 gives 1.88 by 10 to the minus 4 moles. Okay, that's a 9.4 centimetres cubed. Okay, next then I'm going to have a look at my ratio of S2O32 minus is to I2. Ratio there, 2 is to 1, 2 sodium thiosulfates to 1 iodines. So I've worked out I have 1.88 by 10 to the minus 4 moles of my sodium thiosulfate. So I'm going to have that multiplied by 1 divided by 2 to give me 9.4 by 10 to the minus 5 moles of iodine. And that's 9.4 by 10 to the minus 5 moles of iodine, and that's in 200 centimetres cubed. And I have to work out what that is in moles per litre. So I multiply 9.4 by 10 to the minus 5 by 1000 and divide by 200, which gives me 4.7 by 10 to the minus 4 moles. Okay, and that's my answer to that part. Okay, I'm asked for it in moles per litre. Next then I'm told that for every 1 mole of dissolved oxygen, I have 2 moles of iodine produced. So my ratio here is 1 is to 2. So what we have to do here now is calculate the concentration of dissolved oxygen in the river water sample in moles per litre. So if I look here, I've worked out I have 4.7 by 10 to the minus 4 moles of iodine. So I multiply by what I know, which is by 1, and I divide that by 2, which gives me 2.35 by 10 to the minus 4 moles. Okay, sorry, that's the answer. Okay, then we're asked for that in grams per litre. So number of moles equals mass in grams divided by my relative molecular mass, and it is my relative molecular mass of dissolved oxygen, which is 16 by 2, which is 32. So it's 2.35 by 10 to the minus 4 multiplied by 32 gives me an answer in grams per litre of 7.52 by 10 to the minus 3 grams per litre. That's my answer to part 2. And finally then, to get that answer into ppm, I multiply it by 1000, and that gives me 7.52 ppm, and that's my answer to part 3.